అరే ఏంటిది ఎయిట్ ఏంటిది? అరే అది కాదురా.
Hello. So we'll start our discussion on this basics of SQL, right? As we'll continue our discussion, what we did regarding your exam result, etc. Will be inform you within couple of days. Within few days, we'll be informing you regarding your uh, evaluation of the this quiz one. Okay, so let me share the slide. Give me a minute. Okay, so last class, rather yesterday, we were discussing about this general syntax of SQL. Uh, Rather, we are talking about Cartesian products, and okay. So there is a construct of rename operation that also we have seen, and which comes with a self joining, and this string operations. Here we were right. We are discussing about this uh, string related operations. So the one is there is the what we require is that like clause, right? So the includes a string matching operations. The operator like uses the pattern like select name from instructor where name is like star dar star. That means anywhere this word dar is there will be those string will be compared with. So if we give a star, sorry, a percentage. So if I give this percent sign, then it will be matches with any substring of this, any substring type. If we give underscore, then it matches with the character, right? Like here, if we give 3 underscore, to matches any string of exactly 3 character. But if I have 3 and this percent, then matches with any string at least 3 character followed by any other string. Right? So similarly, there are other string operations like concatenations, converting upper to lower and things like that. So that you can refer to that any standard manual or literature. So other options what we have is order by. So order by is by default ascending. So select distinct name from instructor ordered by name. Right. So why we have given this, we have used these words distinct because there may be more than one person with the or more than one instructor with the same name. So in order to have only the distinct name, so distinct name and ordered by the name, so automatically it will be in the ascending order, right? And if we want it to be descending order, then we have to specifically give a DESC or the descending, that specify the term DESC. Right? So it can sort multiple attributes like sort by department name and things like that. So this in the predicate we can use the word between this comparison, like find the names of the instructor with salary between some 9,000 and 1 lakh. $100,000. So salary between so and so. So we can have other construct also, but this type of things is possible. So even we can do a sort of a tuple comparison, like where this instruct ID department name equal to teacher's ID biology, right? So that type of in the where clause, those type of predicate also we can use. So if you see, there is a pretty strong construct, right? And several set related operations are possible, like select so and so, union so and so, right? And similarly intersect, except that find courses that ran in fall to 2009 but not in spring to 2010. Then we have uh, this except query. So find all those things except those course IDs which are available in 2010. So this find the salary of all instructors that are less than the largest salary. So first of all, this is some sort of a doing a joining the instructor with instructor. So what we are doing is renaming as a T and S, where T dot salary is less dot salary. So it finds all the salary less than the largest salary eventually. Okay. And we'll see some other subquery type of construct. Find all salaries that of all instructors. Right. So that is we take out the salary column, that or the attribute salary. So select distinct salary from the instructor relation of the instructor table, and distinguish all those unique salaries. If there are repetitions, those repetitions will be removed. So find the largest salary of the all instructors, select the second query, that is distinct salary, and the first query where you have the all the salaries which are less than the largest, right? So select this except this particular salary. So if we see based on that our this union, intersect, and except query. So each of the above operations automatically eliminates the duplicates, right? To retain all duplicates, use the corresponding multi-stage version of union all, intersect all, except all, right? What we have seen that select all, right? So if you want to keep the duplicate, so you have to give the this all. We have to use this all keyword, right? Along with this thing, like except all, union all, or intersect all things like. So we have in case of a union. So if we give that union all, then m plus n times the occurrence will be there. So minimum if we intersect all, minimum of this, and max of 0 m minus 1 if we give except all s. So there is a special case with the null values, right? So usually database designers or they don't want null value, or this null value creates a lot of confusion in the things. So as far as possible, the null value should be avoided. But there can be null things. Right? Some of the constant we put that, like the primary key cannot be null. There can be we can put integrity constant like say name not null, right? Roll number not null, type of things where you need to provide this fields, that is mandatory fields or mandatory attribute data values. So it is possible for all tuples to have possible to have null values denoted by null for some of their attributes, like say student do not declare, somebody that instructor do not declare their salary, or that is not updated for a month, then that can be a null value. So null signifies an unknown value, or that a value does not exist. Right? So it's so the result of any arithmetic operation involving null is null. So 5 plus null is null, right? So the predicate is null can be used to check the null values, right? Find all instructors whose salary is null. So we can say select name from instructor where salary is null, right? So these are the things sometimes required when you want to do some calculation for say finding this gross salary or income tax calculation, etc., where you don't want the null to be coming into play. Right. So these are the things which are there. So aggregate function, these function operate on the multi-set of values of a column. Like I can average, mean, max, sum, and count. So these are the aggregate functions which can be used with the this in our SQL queries. Right? So like find the average salary of instructor in a computer science department. So select average salary from instructor where department equal to com science. Right. So it aggregate all the that salary column and makes a average of the thing. So select average salary of the. Find the total number of instructor who teaches a course in the spring 2010 semester. Right. Select count distinct ID from teaches where semester equal to spring and year equal to 2010. Right. Find total number of instructors who teaches a course in the spring. Right. So we can count by the count distinct ID. So if that there are if the same instructor is there in multiple courses, so that we want to find the distinct ID from the teachers and the for the spring 2010. So find the number of tuples in the course relation. If you want to find the number of tuples, number of times it is required, select count star from the course, right? So there are when we want to look at the number of tuples from the from any table in this particular is the course relation, right? Course table. So these are the popular aggregate functions which you can use for different purposes. Like here, like the same things what we have seen, that we want to display department name, average salary for instructor, and we want to make a group by thing, right? So average salary of computer science, average salary of biology, average salary of say physics department, and so on and so forth, right? So the clause what we can use is the group by. So department name, average salary. So we are renaming as AVG underscore salary in the output column, which is coming up out here, right? We can have any other sensible name here. From instructor table, group by the department. So it is grouped by the department. Okay, I can have if other things are there, I can use group by context in different. So the attribute select clause outside the aggregate function must appear in the group by list, right? So here it is this attributes in the select clause, right? So here the attributes in the select clause is department name and ID. So is basically what we are trying to do. That attribute set should be in the group by clause. Like here you see the attribute is the department name in the select clause, what is in the group by clause. But here department name ID, but that is not appearing. But if I want to have this sort of a thing, then there is another clause of the having clause, right? Where I can say that having salary something or having some other operations, right? So group by department name, and then the name and average salaries of all departments whose average salary is greater than this. So the predicate having clause are applied after the formation of the groups, whereas the predicate where clause are applied before the formation of the group. So when we say where something, so that is based on the this from whatever the joining is going on, like from instructor, comma courses. So from that Cartesian product, we are using this where clause and type. But when we are having, so group by so and so having something, right? So it is this, but this having predicate is applied after the formation of the groups by the group by clause. So total salary, select some salary from instructor, right? Like as we this another aggregate function. So above statement ignores the null amounts, right? So if there are say total number of instructor is 20 and there are 5 salaries not available, that means denoted as null. So it is a null amount. Result in null if there are all are nulls, and none of the salaries are updated, so it will result in a null thing. So all aggregate operation except count star ignore the tuples with the null values on the aggregate function. So count star basically count the number of tuples, right? So if all are null values, then the count star will do not find any tuple with any non-null value, so it will return 0. So there is no tuple with non-null values, right? Whereas for all other aggregate functions, the output will be null. Okay. So next is nested subqueries, right? So we can have subqueries nested within this basic construct, right? So we have select from where, that is the basic construct. So SQL provide mechanism for nesting subqueries. A subquery in a select from where expression that is nested within the another query, right? So it can be with respect to the where, with respect to the from clause, or even with respect to the select clause. The nesting can be done in the following, say, construct. So A1 can be replaced by a subquery that generates a single value, right? AI, sorry. So Ri can be replaced by any valid subquery. Predicate P can be replaced by an expression of the form B operation subquery, where B is the attribute and operation defined will be defined later. Let us see. So if we have in the where clause, right? We are means something bottom up approach. So if we see from the where clause, so a common use of subqueries is to perform test on a set of for set of membership, set of comparison, set of cardinality of the different relations, right? So let us see that find the courses offered in fall 2009 and spring 2010. Okay. So select distinct course ID from selection where semester equal to fall, year equal to 2009 and course ID in this. Right. So though definitely we may have other way of constructing the queries, but here just to explain the use of subqueries, we are using this type of construct. Right? So it can be select distinct course ID from section, right? So semester equal to fall, year equal to 2009 and course ID in another select statement which returns course ID from section semester equal to spring and this. So, so what we get that the course ID is offered in fall 2009 and also in spring 2010. Find the courses offered in fall 2009 but not in spring. Right? So instead of in, we use here not in. Right? So these are using to set membership, right? So this, so we can have other type of things like find total number of distinct students who have taken courses, section taught by the instructor something 10101 instructor ID. So we find out the this count distinct ID from text, right? That is the student ID. So courses, course ID, where course ID, section ID are in, excuse me, course ID, section ID, semester and year. In select course ID, section ID, semester, year from teachers and like this, right? So what we see that find total number of distinct students who have taken the course in the course ID. So we can have this sort of a constant, right? So want to find a set of things like course ID, section ID, semester, year, which is present in this particular subquery set. So the above query can be written in a much simpler manner, right? Definitely, or there can be alternative. Rather, many of the queries can be written in much, in some cases simpler, or in some cases alternative way. So what we are using it to illustrate the SQL features. So as now we are discussing with the basic features of the SQL, which some of the or many of these features are already you have already used in your lab assignment. So that's why all these queries, as we were discussing, may have other way of representations, right? So of course, which will be the efficient way of representation? So there are this optimal query, how to find out. So those are challenges. So that we'll see in later in the things. I think somewhere chapter 12, 13, that this type of optimization, query optimization, query processing and optimization related things we'll see, right? So it depends in lot of other features, other things other than only the number of attributes, also the cardinality of the things, right? So there are other. So we may need to form a query execution tree and see where if without keeping the integrity in the sense the result same, whether we can change this the query construct. Okay, that we'll see later on. As of now, is basically see that what are the different type of features available, right? In that. So there is another construct of for sum clause, another clause called sum. Find the names of the instructors with salary greater than that sum. That means at least one instructor of a particular, in this case, biology department. So select distinct T name from instructor as T and instructor as S, as we need to join with the same relation. So T dot salary is greater than H dot salary and is dot department equal to biology, right? So that we will find out that which are the names of those instructors whose salary is basically have a more than the salary which is at least of one, right? So if you visualize when we do a instructor T cross A's, so in that particular table we have T dot salary and S dot salary. So wherever T dot salary is greater than H dot salary and the department equal to biology or department name equal to biology, those will be filtered. So same query using this sum clause, right? So we can, so this is the standard way of using. So if we use the same query using the sum clause, then we say select name from instructor where salary is greater than sum, select salary instructor equal to biology, right? So this says that at least one of the things is more than the salary of this subquery. It will be returning that it will be giving in the as a output tuple. So this is again that just to that how the sum is defined. So for comp sum say R is equivalent to there exists a T where belongs to R such that if comp T. So if we see these comparisons like it will be less than equal to greater than equal to and not equal to, and this is true. This is already we know. So in other sense that equal to sum is equivalent to in, but however not equal to sum is not equivalent to in, right? Not equivalent to not in, right? Like that is anyway that is from our knowledge of set theory. We also know this this logic, right? Like here the last statement what it says. So there is a all clause. So there was a sum clause, that means at least one. All clause that define the names of all instructor whose salary is greater than the salary of all instructor of the biology department. Right? So we have instructor salary greater than all. Select another subquery. Select salary from instructor department equal to biology. Right. So this is a all construct. Sorry. So here also in this construct also not all is equivalent to not in, but equal to all is not equivalent to not in, right? In the with the same from our basic logic. So this need to be kept into mind, but anyway that is not a that if you want to use in the other. The exist construct returns a value true if the argument subquery is non-empty. So exist R is not null, right? Non-exist is R equal to null. So like find all courses taught in both fall 2009 and spring 2010. The same we are bringing the previously we have seen this query where we have used this in, right? And course ID in, like offered in fall and 2010 in course ID in. And if we are using not spring 2010, then not in. Right. Here we are using exist, right? So so what we are doing, course ID equal to this, selection section as is, semester fall, and year 2010, where this particular is dot course ID and T dot course ID, this predicate exists. Like semester is being 10 and this course ID, at least there is one tuple. It is a not null type of scenario, right? So variable is in the outer query, and what we are using this variable is this particular variable is like this section renamed as is dot course ID as the inner tuple we are comparing with the t dot course ID, right? So we have this clause not exist also in some cases. Find all students who have taken all courses offered uh, all courses offered in the biology department. Select distinct so and is dot student dot id student dot name from student as is, where not exist select course id from course where department equal to biology except course id which has taken where sid equal to tid, right? Okay, so so if we see the thing of there that not exist says that is a equal to null. So you will not get such cases where things will be such students are there. So it will return those students which has taken these courses in the biology. So first nested loop list all the courses offered in biology. Second nested loop all courses of a particular student. Right. So note that x minus y equal to null. This implies that x is a subset of y. Cannot write the query using equal to all and its variants. There is a typo. This is when we want to use the subqueries in the from clause. It is there in the FORM. So what we see that where clause. Now this, we can run subqueries in the from clause. SQL allows subqueries expression to be used in the from clause. Find the average instructor salary of those department where the average salary is greater than something $42,000 or so. Right? So department name average salary. Select department name average salary as ABG salary, renaming at that this for the output column. From instructor, group by department name. So where average salary is some 42 greater than 42,000. Note that we do not need to use having clause here, right? I could have used those in other constant. Another way to write the above query: select department name average salary from select department name average salary from instructor group by department as department department name average salary, where average salary is greater than 42. So we can have different type of construct. So what we want to show here that you can use a subquery with select from group by clause or select from where clause in the from construct. There is another clause with clause. Right? The with clause provides a way of defining a temporary relation whose definition is available only to the query in which the with clause is. Right? So we create a temporary relation. So find all departments with the maximum budget. Right? So with max budget value as select max budget from department. Right? So and select department name from department comma max budget. Right? Department budget equal to max budget dot value. Now see this particular max budget in this case was constructed using this, or this relation has been generated using this temporary relation is generated using this your with clause, right? So that can be used for the rest of the query, right? Rather can be used for the subsequent select from else that query, but it is a temporary, it exists only for this query, right? So we'll see later on, or that there are we can create other way of reusing these things. We can create different database views, which is something the operation this what we say that utility is something like this sort of utility where you create a particular temporary table, but which can be used by other queries as well. So some complex query with clause, find all departments where total salary is greater than the average of total salary of all departments. So find those departments where the total salary is greater than the average salary of the total salary of the all departments. Right? So that means I find those departments whose total salary, if I make average of the salary of all other departments, it is more than. So department total, department name and value, right? So as from this subquery, select department name, sum salary, okay, and from instructor, group by department name, and department total average value. As now use this department total, which is with that with clause, right? And use that department total average value, and use this department total average in my select from where clause. right? Select department name, department total average, and where the department total value is the greater than the department total average values. So we can have this sort of a more complex with clause, right? So what I trying to do in some of the cases, you can always do something where these group by these having source clause and other subqueries, but in this case we are generating or generating some temporary relations which are used by these subsequent subqueries or subsequent queries. And finally, we can have the select queries in the select clause. So we had select from where. So we have seen that from the where, then the select, and the from, and then the select clause. The scalar subquery. The scalar subquery is one which is used where a single value is expected. Right? So this is as the name also suggests. So what is expected that it will return a single value. List all department along with the number of instructor in each department. Right? Select department name, select star, and so forth as num instructors from department. Right? So runtime error if the subquery returns more than one result tuple. So once we have only if I expect that a query where it returns only one tuple, then I can have this select this scalar subquery. Okay. So this what we try to see here, that what are the different type of construct available with either from or select. This is that where and the select clauses, right? So these are what are the different subqueries we can run from the where, from, and this select subclause. So now let us see other things which are modification of the database. We may not need these queries much because for a running database, modifying is always create lot of complications in the terms that there may be lot of relation defined, lot of what we say, what would you say that some constant defined across tables and things will be all will be little messed up if we do delete, insert, and things. But we require these queries to update our to modify the databases. So three things are required: deletion, insertion, and updating the database. So delete of the tuples from the given relation, insertion of new tuples into the relation, updating values in some tuples in the things. So this is not modifying the schema like as we have seen in the beginning, like you are deleting, you can drop a table, alter a table. Those are using the actually you are changing the database schemas, right, or the basic structure of the relations. So those are quote unquote more dangerous because some data things which are there, it cannot be accessible and things like that. But here is basically more on the, so you are not changing the attribute per se of the things, but you are changing the values of different tuples. So delete all instructor from the all tuples from the instructor relation. So delete from instructor, right? So delete all instructor from the finance department. So we can delete from instructor department name equal to finance. Right. Delete all tuples in the instructor relation for whose instructor associated with a department located in something, Watson building in this case, right? So delete from instructor department name in a subquery. So this type of things are possible. So I can have a subquery to find out that which need to be deleted or things like that. Right. So deletion in this form are possible. So there are other deletion like delete all instructor whose salary is less than average salary of the instructor. Like delete from instructor salary less than this, so and so forth. Right. So that means like I maybe I want to see that how many people are above average salary. Though I can have other constant, but or I want to delete all things where the salary field is null, right? So eliminate all those things for and look into the things. Or I can want to have means copy the things into another two table and delete something here and there. Anyway, so problem as we delete tuples from the deposit, the average salary changes. So this is a challenge, right? So once you go on deleting, the average salary may go changes. So first compute the average salary and finds all tuples to delete. So it is solution is that first compute the average salary and then do the compute to this. Next, delete all tuples found above without recomputing the average and resetting the tuples. Right. So I can have first do a computation of the salary. Because what happened that your average salary is dependent on the salary field itself. Right. So in this case, we need to first calculate the average salary. So by this or with clause and then run that delete operation. Similarly, we same the other way around. If we are deleting, we can insert into, right? So insert into say some course with course ID, course name, department, and credit. Right. So as it is equivalent to insert into course with the values so and so. Right. So these are this is equivalent. Or add a new tuple with total credit to set as null. So I can have this as a null. But the constant here is that the field which are not null, that means maybe the course ID or the course name, if they are declared as a not null, or a department may be a foreign key from other department, from a department table, and those are if set to not null, and those you cannot set to the null, right? So you cannot insert like this with the null as the say course ID value. Okay. So there are other instruct things like instruct all instructor, add all instructor to the student relation with total credit set to 0. Okay. So insert into student select ID, name of the department, this from instructor. So this something is there. So we can have select from where statement is evaluated fully before any of its results are inserted in the relations. Like say insert into table 1, select star from table 1. Could otherwise the queries will form as we have seen delete here also that it may create a problem. So it is select is evaluated before any insert goes on, right? In the same case what we have seen in the previous scenarios. Updates. Increase salary of the instructor whose salary is over something $100,000 by 3% and others by 5%. Right. This is if there is an increment and the government has a and the company has a logic of that if it is so and so you increase by this, if it is so and so increase by this, then then we can have this sort of. So write to update statement, update instructor set salary this where salary is greater than this, update instructor where this salary is this. Order is important because that if it is updated and then goes into the other range, it can be again again the application can be executed. So this is important not only for these updates, any of the things which modifies the database tuple. That means wherever there is a update of the update, deletion, insertion of the tuples goes on, and if your calculation is based on those things, so you need to be careful that which order and it is being executed. Right. So this is important to understand the and means you need to keep in mind. So it is intuitive, but it is important to understand. I think this is the basic things what we think. There are something which is given in the slide, so there is maybe some typos in the that particular things, but anyway that is okay. So this is about your uh, basic of basics of let me unshare this. Uh, okay, keep it set. So basics of SQL. So subsequently we'll go for something which is little bit what we call something intermediate and advanced SQL, which is mentioned in the you find in the book also. So if you have any query, we can take up, or we'll otherwise we'll close for today.
Sir, in the test, this in this lab class, how tough will the queries come?
How
Like, what will the level of difficulty? Like, the queries that which you taught in the class, like in that level or anything else?
the test in the sense you are telling the next test?
The current lab, this week's lab session.
Oh, acha, this lab test that will be these are very basic things, right? I think this is the fundamental level of stuff. But what I believe that with this, if you are gone through this, so it will be you should be able to do those queries, right? So we'll be using the construct whatever has been told, but the it may not be very straightforward, right? But the construct wise, it will be the things. You know, no need of having new clause or construct to be known. Right? Complication will be in the logic,
Okay.
not on the what we say using not on that you need to know other construct which is not been discussed. Okay.
Okay.
Okay. If you do not have any other query, we may close now. So we'll start with the next level of things in the next class.